All right, now let's look at the tangent graph.
I'll
Remember, tangent starts at a 0, okay? Its period is pi, so at pi there would be another 0, and at 2 pi there would be another 0. And then halfway between those zeros is an asymptote. So we're going to draw an asymptote at pi over 2, and an asymptote at 3 pi over 2, and an asymptote at negative pi over 2, and an asymptote at negative 3 pi over 2. Okay. Remember, also, since the period is pi, the critical points happen at every pi over 4. So that means that at pi over 4, it's also going to the angles, so it's going to be at 1. And at negative pi over 4, it's going to be at negative 1. And then we can graph our nice little period of the function. Okay, well, again, this function all by itself is not one-to-one, because if I drew a horizontal line, it would hit the thing about once every pi, and it would hit it over and over and over again to infinity. So we have to restrict our values so that we know, so that it will be one-to-one, at least during in that restriction. So which one would be nicest to restrict?
Well,
Well,
the one closest to the y-axis is...
Yeah, the one that's continuous. Oh, continuous.
Uh-oh.
Continuous, meaning you don't have to pick your pencil up between the values, would be from negative pi over 2 to pi over 2. Okay, but we can't have a value at pi over 2 because it's undefined.
So these should be...
Parentheses.
Not including those.
All right, so tangent inverse is in the interval negative pi over 2 to pi over 2, not inclusive, okay? And tangent has more than negative 1 to 1. Tangent is negative infinity to infinity.
It sure does. And so you know what we're going to do? You can cut that, and we will fix this. So we made a cut. Yeah.
Well, their notes are going to say this. So we've got negative infinity to, not including infinity, Miss Talkstater.
I know.
Negative infinity to infinity for v, because tangent has all the values, and the unique number negative pi over 2 to pi over 2
Not inclusive.
is u, not inclusive.
Now you'll notice when you get your notes, you should already have your notes. Those corrections that I just had to make are already made on your notes. So.
Okay. All right, and also the tangent inverse of the function tangent of u equals u if u is between negative pi over 2 to pi over 2, and tangent of a tangent inverse of v equals v for every real number v. See, that works.
So just remember, pay attention to that negative 1. If that is on the outside, we are looking for an angle in a special place. Okay, that's
We're looking
really
for the toaster
important.
at your house.
Okay, very important. All right.
Looking for the toaster at your house. Okay.
So, notice, what do we notice?
So, we are looking for the angle whose tangent is negative 1. It's negative, that means we're going to look on the interval between negative pi over 2 to 0. Negative pi over 2 to 0.
We're in quadrant 4, but
Okay.
it's got to be negative pi over 2 to 0. So, here we go. Boom.
Tangent whose negative 1 is where the sine and cosine are equal to each other, and that would be at the square root of 2 over 2 and negative square root of 2 over 2, which is negative pi over 4. 4. Negative pi over 4. Ta-da! Okay. All right. For B, the tangent inverse, we're looking for an angle whose tangent is negative 14. Oh, not a point that we know on the unit circle. It is on the unit circle, we just don't know what it is. But we can definitely guarantee that the sine is bigger, i.e. the y value is bigger. So that means it has to be bigger than pi over 4, or smaller. Wait. Sine has to be bigger, so it has to be smaller, i.e. Okay, well, the angle has to be bigger than pi over 4.
Yeah.
Yeah. Okay.
And since we're in quadrant 4, we know that the y value must be negative and the x value must be positive. We don't know that y is negative 14 and we don't know that x is 1. I mean, after all, y could be negative 28 and then x would be 2.
2, okay.
Right? I mean, so
Yeah.
we just know the ratio between the y and the x. But here's the thing. This is another one of those where, gee whiz, we have to actually go to the calculator. And so we need our answer to be on the interval of negative pi over 2 to pi over 2, negative pi over 2 to 0. So if we look at that as a decimal approximation, that's about negative 1.57 to 0, right? And so we go to our calculator, we're looking for an angle, we just type in so tangent inverse of negative 14, and voila, guess what answer it gives us? Negative something. What does it give us?
It gives us negative 1.499.
And look at that. Is that in that interval?
Well, I just said it was going to be bigger than pi over 4, a magnitude bigger than pi over 4, which is 0.79.
Yeah.
So this is definitely bigger than 0.79. So that's, you can use that to think about it.
Yeah.
Oops, there was next one.
And our last example.
Find the example of sine of tangent inverse of 1/2. So first we're going to look for the tangent inverse of 1/2. So let's think about this. It's a positive value, so we're looking in quadrant 1. The tangent where it equals 1/2 is,
It's not a unit circle. We fooled you, but we have y and x, so I don't know. Y is 1, x is 2. I don't know. Maybe we're looking at, I don't know, maybe we're looking at x is 2 and y is 1, maybe.
But we know that the cosine is bigger than the sine.
Mm-hmm.
So that means that it has to be smaller than pi over 4.
Mm-hmm. And how do we know to put that in quadrant 1?
Because it's a positive value.
All right, that is positive. So theta must be in quadrant 1. But here's the thing we don't know. We don't know what theta is. We do know a ratio between x and y. We know that our x could be 2 and our y could be 1. And so if we have 2 squared plus y squared, which is 1 squared, equals our radius certainly is not 1. How do we know the radius isn't 1 in
Well,
this
because
case?
2, 1 is not on the unit circle.
Okay,
2
so
is
here,
not even close.
So here we have 4 plus 1, which is 5 for our radius squared. So our square root of 5 is our radius. Notice that we want the sine of the angle. And what do we need for sine?
We need the opposite.
We need y over
r.
r. And look at that. We have a value for r that goes along with our ratio. So the sine, we didn't know what the angle is.
Mm-hmm.
We didn't have to actually find the angle. You can go to your calculator and find it if you want. But the thing is we know we didn't even need to know what the angle was because we're asked to find the sine of the angle. We just needed a y and an r. And our sine is, y is probably, could be 1. So, but our ratio, no matter what our value is, 1 over square root of 5 or
Square
root of 5 over 5. There you go. We're looking for a value. Notice a value. So you have to read these things very carefully. And here's what was kind of cool about this. We didn't actually have to find our theta in this problem in order to get sine because sine is a ratio. We just needed a ratio to work this problem.
And it tells us that the ratio of the sides is 1 to 2. We just needed to find our radius using that ratio, and then we're looking for the sine now.
Now, this is why, I hope you understand, this is section 8.2, this is why we didn't want to throw this on the test you guys just took, because there's a lot of things that make that material difficult when you really have to start thinking about specific places for all of these things.
Mm-hmm. All right, so for your section 8.2, problem 2, go to section 8.2, work 6, 11, 30, and 36. No calculators, and do the problems. If they get to point, look at example 6, and that should help. All right, and same stuff. 1 new thing you learned, 1 good question, 2 old skills, and don't forget to bring your entrance ticket to class.
And some of you are really boring us with your 1 new thing and your 2 old skills.
Yeah, and your good question.
Yeah.
Make it a good question, like that's pertinent to the material, please.
Yeah. Thanks.
Bye.